Now in this class we will see conic sections. Conic sections. Conic sections. What is the meaning of conic section? Actually, in the conic sections, if a right circular cone is divided or cut with a section plane, what are the different types of shapes obtained? Those are called as conic sections. Now, we will consider a right circular cone. A right circular cone means the axis of the cone is perpendicular to base. When the axis of the cone is perpendicular to its base, then we can call that as the right circular cone. That means this is 90 degrees. Assume that a section plane. Assume that a section plane. A section plane means it is having infinity length, infinity width and perpendicular to the board and parallel to base. Okay, that section plane we can consider, or perpendicular to board, infinity length, infinity width. Okay, that type of section plane we can consider. Okay, before going to consider the different sections, just we will observe how the cone is framed. The cone formed by rotation of a straight line. Suppose if we take a straight line and if it rotates about its axis, if it rotates about the axis, the formed shape is the cone, right? And this straight line we can call it as generator, and assume that the angle of inclination in between base and the generator is alpha. Base and generator is alpha. Okay, now a section plane we can consider. That section plane, first instant we consider it is parallel to section plane, parallel to base. Section plane parallel to base of the cone. Now it is cut like this. Okay, now the section plane cut the cone. Suppose if it cut the cone parallelly, the obtained section here is a circle. This is removed portion, this is retained portion. Now this circle can be given hatching here. This is the shape we got. This is one conic section. Now the other one is, if you consider a right circular cone again, the axis of the cone is perpendicular to the base. This is alpha. Now consider the section plane parallel to the generator angle. Okay, the angle of section plane, angle of section plane with base is theta. Angle of section plane with the base of the cone is theta. And we consider section plane parallel to the generator. This is theta, and alpha equal to theta, or parallel to the section plane. Now this is the removed portion, this is retained portion. Okay, now what will be the shape obtained here? After removing this portion, we can see a shape like this. Okay. If we give hatching, we can see that shape very clearly. This shape is nothing but parabola. This is parabola. Right. That means the second case, the section plane parallel to generator of cone, then formed shape is parabola. The first one is circle, the second one is parabola. Right? Now we can go for the next case. Again, we need to consider a right circular cone and this is axis and this is alpha. Now I want to consider a section plane at an angle of less than alpha. That means theta is less than alpha, where theta is the angle made by the section plane. Right? Now this is the section plane and the angle, this is theta. Alpha is more and theta is less. And I consider all the generators of the cone, it need to be cut by the section plane. Now what will be the shape obtained? See, the shape obtained, it will be like this. Right? And this is removed portion, this is retained portion. To visualize the exact shape, this is the exact shape, that is an ellipse. An ellipse is formed when a section plane having less than the angle of generator with the base, the obtained shape is the ellipse. Now we go for the other one. Again, we need to consider a right circular cone and this is axis and this is base and this is alpha. Suppose the section plane angle is more than the generator angle. For that, I consider section plane like this. Okay, this theta is, we consider 90. Okay, that, but we can show theta is greater than alpha. Okay, and this is the removed portion, this is the retained portion. Therefore, the obtained shape will be like this, right? And this shape we can show in this fashion, right? This is hyperbola. Now we will summarize. Third one, the section plane inclination theta is less than inclination of generator angle. is alpha. Okay, theta is less than alpha. Obtained shape is ellipse. Right. The fourth one is the section plane inclination. Alpha is greater than theta. The section plane inclination here, alpha is less than theta. Ellipse. Alpha is greater than theta, then it will be hyperbola. Hyperbola. Okay. Now, these shapes and these curves, well-defined mathematical curves. Suppose if these are well-defined mathematical curves, just we need to implement the ratios what we have proposed in the mathematics. Now we will see. Consider this is a horizontal line or axis. Right. Now, here consider a fixed point F. This is fixed point F. And I want to consider a line perpendicular to horizontal line. This line we can call it as fixed line. Fixed line. This is fixed point, this is fixed line. Okay. In mathematics, this fixed point we can call it as focus. Fixed line we can call it as directrix. Okay. Now I want to consider the midpoint of this. And now this midpoint I can call it as V. And here this is D. The point V, if you consider V F divided by V D. Now we can say that the ratio in between the point to F, the considered point to D, or considered point to fixed point, considered point to directrix. Okay, that ratio we can call it as eccentricity E. And by maintaining the same ratio, if you draw a curve, the obtained curve will be like this, which is a parabola. The obtained curve is a parabola. This is an open curve. Okay. And here if you consider a point P at this point, and if you consider PF by PD, PF by PD, PF by PD also gives the same ratio. PF by PD also gives the same ratio. Okay. And if you consider another point, that is also gives same ratio. That ratio is nothing but equal to 1, because VF by VD equal to 1, PF by PD1 also equal to 1. Okay. Therefore, mathematically we can define a parabola, a curve which follows the ratio fixed point to fixed line, that ratio equal to 1, we can call that as the parabola. Now another curve I want to consider. Suppose I consider a point here, VE. VE. Now VE by F, VE by D, VE F by VE by D, VED. Suppose if you take this ratio, this is less quantity, this is more quantity, then obviously it is less than 1. Right. If you maintain the same ratio and if you draw a curve, that will give us an ellipse like this. That will give us an ellipse. And this is the minor axis, and in the same distance you can locate another point, that is focus 1, focus 2, right? That means when the E value is less than 1, it will give us ellipse. E value less than 1, it will give us ellipse. And this is parabola. Right. Now, I want to consider a point here. Let it be VH. Right? VHF divided by VHD. VHF divided by VHD. Eccentricity E. Now, if you take this ratio, obviously it is more than 1. The numerator is more, denominator is less. Therefore, it is more than 1. And if you draw, by maintaining the same proportionality, if you draw a curve, the curve will be like this. Okay, this is also a open curve. This is hyperbola. Okay, this is hyperbola. Right. Here, by considering eccentricity, by using mathematical basics, we define parabola, ellipse and hyperbola. And you can observe that the V, that is the point on the curve parabola, and VE is also a point on the curve ellipse. VH also a point on the curve of a hyperbola. Okay. Now, based on this property, we will develop a general method to draw parabola, hyperbola and ellipse. Okay, and this general method also called as eccentricity method. Okay, now we will see how we can use this eccentricity and we can draw the respective parabola, ellipse and hyperbola.